All right, so let's talk about half-angle identities. So if you recall, we learned recently about double-angle identities. So what's a half-angle identity? Well, let's think about the double-angle identities that we did. So let's just do, cosine of 2 theta. We know one way to write this was 1 minus 2 sine squared of theta, right? So this was a double-angle identity. Why was it a double angle? How do I get rid of this? Well, because we're doing 2 times the angle, right? So it was double the angle. But let's actually box this. Double this angle. Another way to think of this is that this angle is half of this here. So the point is that half the angle and double the angle are really the same thing. So for example, let's let x be 2 theta. So that being said, now we have cosine of x equals 1 minus 2 sine squared of, well, now instead of theta, I got to solve this for theta. I get theta equals x over 2. Okay, so give me some blue. This is sine squared of x over 2, if this thing would ever work. Okay, so we have our half angle here. We want the half angle identity. So, we would use algebra because we want to solve for this. We want to use algebra to isolate that half angle part. So if I do that, I'm going to solve for sine of x over 2. So I'm going to subtract 1, divide by -2. If we do this correctly, we get sine of x over 2, the half angle, is going to be plus or minus, because I end up square rooting, plus or minus the square root of 1 minus cosine of x all over 2. Okay, so that's how we could derive these half angle formulas. Now, we won't do it for all of the cases, sine, cosine, and tangent, but they are here. These are things that you'll want to know and understand, and most importantly, know how to apply. Here's an important question here is how do we know if it's going to be the positive or negative? Because for each of these, it's plus or minus square root. So how do you know? Also, notice that tangent has 3 potential options. All of them are correct. You might find one more applicable in one scenario than another. But again, how do you know if it's plus or minus? I want you guys to think about that. Write down an answer, and then we'll move on. Okay, so we're given this triangle here, and what we want to do is find the following. We want to find tangent of theta over 2, so these are all half angles. The secant of theta over 2, and you might be thinking, well, we didn't have a secant half angle formula. Well, we know what secant is, right? So let's think about this. And then do the same for these two below. So let's have you guys try this on your own. Go ahead and put me on pause. So let's see how we did here. Key thing here is first, let's identify that this is -4. It does tell you in your notes that the triangle is in quadrant 2, and I can also just tell by the way it's drawn here, right? It's in quadrant 2. So here's tangent of theta over 2. So this is the half angle. Now tangent in our half angle identities, I know I have 3 options, so I really just chose the most simple one in this case because I have, the triangle and everything. So I did 3/5 over 1 minus 1 plus -4/5, which is 3. Okay. Now secant of theta, now we know that this is the reciprocal of cosine, right? I shouldn't have to even say that. So it's the reciprocal of the identity. Now, I want you to think about why is it positive? Why is it not -1? Because remember, plus or minus. So why is it the positive? Think about it. Okay. So I plug in my values, I get the square root of 10. Next one here. Here, now the key to thing to recognize here is this is actually just the double angle identity for sine. What do I mean by that? Well, I mean, look here, I get the sine of 2 times theta over 2, which is sine of theta, which is 3/5. All right, next one. This one here, I'm just going to find the sine of theta over 2, the tangent of theta over 2 separately, and then multiply by 2. If I do that, and once I rationalize the denominator, which you can, you don't have to, but I got 9√10 over 5. If you did not rationalize the denominator, that would not be considered wrong, so it's fine if you didn't, I should say. Next example, we want to find the exact value of the cosine of the following angle. Okay, hint, there are 2 ways to do this. We actually did an example like this using the sum or difference identities. It's one of the 2 ways you can do it. And you could also use this as a half angle, which I'll leave it to you guys to figure out what I mean by that. So let's have you go ahead, put me on pause, and then we'll check our answers. Okay, so remember I said that there's really 2 ways we can do this. One would be thinking of this as a half angle identity. Also, you could have used your sum or difference. So I decided to show both methods here. This would be using it as the half angle. So I'm using the half angle identity of cosine. So I plug in my values here, and then I end up getting an answer of the square root of 2 plus root 3 all over 2. Okay. If I use the difference identity here, so I know that I'm going to be using pi thirds minus pi fourths because that is pi 12ths. I plug in everything and I get square root of 2 plus square root of 6 all over 4. Those are those numbers again. Came up once more. Now, I wouldn't expect you guys to like convert from one answer to the other. Like both of these really are equivalent. So just don't worry about that. So using whatever method you get, that would be your final answer. All right, let's simplify this expression here. My hint for you is think about what this looks like. It should look like something. Go ahead, put me on pause. Okay, so this looks like the half identity for sine, right? Only difference is we have, instead of just theta, we have x minus 1. So I have sine of x minus 1 all over 2. All right, last example here. We're going to solve between 0 and 2 pi. We have sine of x over 2 plus cosine of x minus 1 equals 0. My hint for you, because we are solving, we want to find one value or a couple values, or just depending on how many, between 0 and 2 pi. Want to find a value for x. My hint is to get this in terms of one trig function first. And it's easier to go with cosine than it is with sine. So let's see what you guys can come up with. Go ahead and put me on pause. Okay, so first thing that I did here is I used the half angle identity for sine. So I rewrote this as plus or minus square root of 1 minus cosine of x all over 2. And I brought this over to the other side so that way I could square both sides. Which, note that that's going to be something we're going to have to think about at the very end. We'll talk about why. So when I square this side, the plus or minus will become positive for sure. And then I square the square root. So this is 1 minus cosine of x all over 2. This here is going to be a perfect trinomial square. Now I'm going to try to get everything to one side. So once I do that, I get 0 equals 1 minus 3 cosine of x, cosine squared of x. This is factorable. If you're not sure how I did that, go ahead and use substitution. Let u equal cosine of x. I got my 2 factors, 0 product property by setting each of these factors equal to 0. And I'm thinking of my solutions between 0 and 2 pi. So I get pi thirds, 5 pi thirds, and 0. Now note here, this is kind of what I was alluding to before. We want to make sure that we check for extraneous solutions. Because in this step, in the step up here, I squared both sides of the equation. Well, we know in algebra, at least I hope we know, now we will, anytime we square both sides of an equation, we have to check for potential extraneous solutions. Because we created that possibility by squaring both sides. But in this case, these are our 3 solutions. All right, make sure we understand how to use and derive the half angle identities.